The efficiency of catalysts in vehicle exhaust treatment. Title: The efficiency of catalysts in vehicle exhaust treatment. One of the main contributors to air pollution is vehicle exhaust emissions. However, the widespread usage of catalytic converters in modern vehicles has significantly minimized the harmful impact of these emissions. 1. Understanding vehicle exhaust emissions. Vehicle exhaust emissions primarily consist of three major pollutants: nitrogen oxides, NOx, hydrocarbons, HC, and carbon monoxide, CO. These substances are known to contribute to smog formation, respiratory problems, and climate change, making the need for effective exhaust treatment imperative. 2. The role of catalytic converters. Catalytic converters are essential components of modern vehicle exhaust systems. They are designed to convert harmful pollutants into less harmful substances before being released into the environment. Catalysts within the converters accelerate specific chemical reactions, facilitating the conversion of toxic gases into less harmful forms. Platinum, palladium, and rhodium are commonly used as catalysts due to their high activity levels. 3. Reduction of nitrogen oxides, NOx. NOx compounds are major contributors to air pollution and contribute to the formation of smog. To reduce NOx emissions, vehicle exhaust systems employ a catalyst that promotes the conversion of nitrogen oxides into nitrogen and oxygen. This process, known as selective catalytic reduction, SCR, takes place in the presence of ammonia generated from an onboard system. 4. Conversion of hydrocarbons, HC, and carbon monoxide, CO. Hydrocarbons and carbon monoxide are byproducts of incomplete fuel combustion. These pollutants can be converted into carbon dioxide, CO2, water, H2O, and nitrogen, N2, using oxidation catalysts. Oxidation catalysts enhance the rate at which these reactions occur, reducing the emission levels of HC and CO. 5. Emission control technologies. To regulate exhaust emissions, governments worldwide have implemented stringent emission control standards. These standards define permissible pollutant levels and require vehicles to meet specific emission limits. The use of catalysts has been a key technology in meeting these requirements, ensuring vehicles comply with regulations and significantly reducing pollution levels. 6. Challenges and limitations. While catalysts have proven to be highly effective in reducing vehicle emissions, several challenges and limitations exist. One such challenge is the limitation in catalyst efficiency during engine cold starts when they take longer to reach their optimal operating temperature. Additionally, catalysts can be poisoned or damaged by certain compounds present in fuel additives or engine oil, reducing their effectiveness over time. 7. Advancements and future prospects. As the automotive industry continues to evolve, advancements in catalyst technology are being pursued to further enhance emission control. Researchers are exploring the potential of alternative catalyst materials, such as metal organic frameworks, MOFs, and nanomaterials, to improve the efficiency of exhaust treatment systems. Additionally, the development of advanced control algorithms and integration of smart sensors aim to optimize catalytic converter performance. 8. Conclusion. Catalytic converters have undoubtedly revolutionized vehicle exhaust treatment, effectively reducing harmful pollutants and mitigating the impact of air pollution. Through the use of catalysts, all emissions such as NOx, HC, and CO are converted into less harmful substances, contributing to cleaner air and improved public health. 9. Environmental and health benefits. The efficiency of catalysts in vehicle exhaust treatment has resulted in numerous environmental and health benefits. By converting harmful pollutants into less harmful forms, catalysts have played a significant role in improving air quality and reducing the risk of respiratory problems. This is especially important in densely populated urban areas where vehicle emissions can have a significant impact on public health. 10. Economic implications. In addition to their positive environmental and health impacts, catalysts in vehicle exhaust treatment also have economic implications. With the implementation of emission control standards, the automotive industry has had to adapt by incorporating catalytic converters into their vehicles. This has led to the growth of the catalyst manufacturing industry, creating jobs and stimulating economic development. 11. Role of government regulations. Government regulations play a crucial role in ensuring the efficiency of catalysts in vehicle exhaust treatment. By setting emission standards, governments incentivize automotive manufacturers to prioritize the development and implementation of effective catalyst technologies. Stricter regulations often lead to the adoption of more advanced catalyst materials and systems, pushing the industry towards continuous improvement in exhaust treatment efficiency. 12. Importance of maintenance. To maintain the efficiency of catalysts, regular maintenance is crucial. Over time, catalysts can become degraded or damaged, resulting in decreased effectiveness in reducing emissions. Vehicle owners should adhere to recommended maintenance schedules, which may include inspections and replacements of worn-out or faulty catalytic converters. Proper maintenance not only ensures optimal exhaust treatment efficiency but also extends the lifespan of the vehicle. 13. Awareness and education. Raising awareness about the importance of catalysts in vehicle exhaust treatment is essential. Educating the public about the role of catalysts in reducing air pollution and promoting cleaner transportation helps to foster a sense of responsibility towards the environment. Increased awareness can lead to support for further research and development in catalyst technology, as well as the adoption of greener transportation alternatives. 14. Global collaboration and knowledge exchange. Efforts to improve the efficiency of catalysts in vehicle exhaust treatment can benefit from global collaboration and knowledge exchange. Sharing research findings, best practices, and technological advancements across borders can accelerate the progress towards more effective catalyst systems. International collaborations can also help address region-specific challenges and develop tailored solutions to optimize exhaust treatment efficiency in different geographical contexts. 15. Conclusion. The efficiency of catalysts in vehicle exhaust treatment is crucial for reducing air pollution and its negative impacts on human health and the environment. Through the use of catalytic converters, harmful pollutants like NOx, HC, and CO are converted into less harmful substances, contributing to cleaner air and a healthier living environment. Title: The efficiency of catalysts in vehicle exhaust treatment. One of the main contributors to air pollution is vehicle exhaust emissions. However, the widespread usage of catalytic converters in modern vehicles has significantly minimized the harmful impact of